Hey, all you cool cats and kittens. I think this is the last set of videos for you all. So on Monday, 5/11, there's no PDN. Cool. Moving on. So we're going to skip 63 and 64, and we want 65. So calculate each of the values of the below, then justify your answer by writing the equivalent exponential form. So you're going to have a log base b of a equals x. And then just remember, b to the x is equal to a. So in this case, you need to rewrite this with a base of 2. So it's log base 2 of 2 to what power gets the 32. I think it's 2, 4, 8, 16 to the 5th power. So then this is equal to 5 because these two items, like log base 2 of 2, cancels. And you're left with whatever your exponent is, which is 5. So here, this one is a hard one. To get 1/2, you need to write log base 2 of 2 to some power. So 2 to what power gets you 2 on the bottom? Super hard. Whenever you see a fraction, it's usually a negative, and then the first power. So it's equal to -1. I'll go over a little bit more of that in a second. Like this one here in G. You see a fraction, it's log base 2 of 2, and then because the fraction's negative, and then 2 to what power gets you 16? It's 4. So the answer is -4. So whenever it's a fraction, it's going to be negative. 2 to the what power gets you 0? Never. So this is no solution. I actually think the word is undefined is what you want to use. This one, 2 to the what power gets you to 4. So 2 to the what power? 2 squared gets you 4, so the answer is 2. 2 to the what power gets you 2 to the 3rd power is what? That's super nice. So it's 8. Working backwards. This one, to the 1/2, that's the one. 2 to the 1/2 power. Log base 2. 2 to the 1/2 power is the same as the square root of 2. So you could write 2 to the 1/2. And then log base 2 question mark equals 0. 2 to the what power gets you 0? Or 2 to the 0, sorry. Equals 1. So log base 2 of 1 equals 0. Kind of tricky. So 5-66. The idea behind the ancient puzzle is more than 2,100 years old. The symbol log is more recent. It was created by John Napier, who was a Scottish mathematician in the 1600s. The word log is short for logarithm, and represents the power to which a fixed number called the base must be raised to produce a desired number. The log function represents the inverse of an exponential function. So if you have y equals b to the x, the log of this, so it's going to be, the inverse is log base b of x equals y. And this is the original, and this is the inverse. The way I look at it, I'll give you some real numbers. Y equals 5 to the x. So the way to get rid of to find the inverse, you switch them. So x equals 5 to the y. 5 to the y. And then to get rid of the 5, you have to use this thing called log base 5. My voice is acting funny. I'm sorry. Log base 5, this cancels. So you have y equals log base 5 of x. So hopefully that helps you. So here, determine the inverse. So switch them. X equals log base 9 of y. to get rid of the 9, you have to exponentiate it. So you put a big 9 here and a big 9 here. So then this cancels. You just have 9 to the x equals y. You could just use the rule of y equal x equals log base 9 of y. 9 to the x equals y. So you can use that rule too. You have base 10. So y, I got x equals 10 to the y. What I normally do is you write log base 10. This cancels. You have log base 10 of x equals y. This one's special. Whenever you have the word log, like say you have log of x, you don't have the number right here. If you don't write it, it's 10. That's because our number system is base 10. So if you ever see like log x, that just means log base 10. So this one, yeah, switch it. Or x equals log base 6 of y plus 1. I'm going to exponentiate it. Big 6, big 6. This cancels, so 6 to the x equals y plus 1 minus 1. 6 to the x minus 1 equals y. 2 to the x, so x equals 5 to the 2y. I'm going to use log base 5. Those cancel. Log base 5. So I have log base 5 of x equals 2y divided by 2. Y equals log base 5 of x all over 2. So you can do 1/2 log base 5 of x equals y. 67. Practice your logarithm fluency. So this is just log base 7 of 7 to what power gets you 49? 2. So interest 2. 3 to what power gets you 81? I think it's 4. The 5's in the log base 5 and the 5 cancel, so you have just 7. Log base 10 and 10 just cancel, so you have 1.2. These cancel, so you just have w plus 3. More practice finding inverses. So switch x equals 2 to the y minus 4. I'm going to log it. Base 2. Why do I pick 2? Because that's the base right here. Cancel, so y minus 4 equals log base 2 of x. I'm going to add 4. Log base 2 of x plus 4 equals y. I'm going to switch these. X equals 7 to y plus 3 minus 1. First I have to add 1. Log base 7. Log base 7's cancel. So log base 7 of x plus 1 equals 2y plus 3. I'm going to subtract 3 and then divide by 2. Go ahead and try 3 on your own and try 4 on your own. Hit pause. Try them on your own. And here are the answers for you if you wanted to see them. So that is 5.1. So here's homework. Part 1. Cool. And then now do the PDN. This is 5.2.3. So this is something to the second power equals 36. And that something is 6. This is 14 to the negative 2 equals that 1 over 196. Yep. This is 81, nope, 3 to what power equals 81? No, 1/2, so 289 to the 1/2 power equals question mark. I think that is 17? This cancels, you have 1.7. This cancels, x plus 2. Ooh, this is a good one. So you need to rewrite this to be log base 2 of 2 to the 2nd power to the 5th power. Those cancel, so it's 2 times 5. 10. Good question. So this is log base 7 of 7 squared times 2y minus 5. Those cancel, so you have 2 times 2y minus 5, 4y minus 10. Good question. All right, 5.2.3. Okay, 5.2.3, investigate the family of logarithm functions. In the last 2 lessons, you've learned what a log is and how to convert an equation in log form to exponential form and back. In this lesson, you'll explore the family of logarithmic functions. You can use Desmos to explore the effective b. You may type in y equals b dx, and then use a slider bar. So y equals b to the x. Add slider. So when b is 1, it's a straight line. Is it increasing or decreasing? No. None. And this is none. Because it's a straight line. Let's do b equals 0. When b equals 0 to any number is always 0. Now I'm going to do b as a decimal. And then the decimal between 0 and 1. It's going to just look like that. And then when it's less than 1, when it's less than 1, no graph. When it's greater than 1, you get a nice big graph like that. So when b is greater than 1, that goes there. And then okay. So this graph is increasing. It's getting more and more and more. This graph is decreasing. It's getting less. And this graph is none again, and then none. This one has an asymptote. Horizontal asymptote at 0. So y equals 0. And the same with this graph. Y equals 0. I graph the log. Functions. Log base b of x. Mirror image. So hide this. Put it at 0. No graph. Put it at 1. B is equal to 1. No graph. B is decimal. B is whole number. So this one is B is a whole number. That one goes here. That one goes here. Plus photo library. That goes there. So this graph, it's increasing. This graph is decreasing. None. 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 And asymptotes, we have a horizontal one at x equals 0. And we have a horizontal one at x equals 0. I know it looks like it's not going and it has an asymptote here, but it does continue on forever, getting bigger and bigger. So just keep that in mind. So there's your family functions. Here's your HW. Part 2. All right. This one, PDN. Given the graph below, draw its inverse function. So I like to use this point, so that's 0, 1. So it's 0, 1, so you switch it to be 1, 0. And this is 2, 2 1, 2, so it's 2, 1. And that's 2, 4, so it's 4, 2. This point is, then it goes like this. What is the original function? This is y equals 2 to the x. The original range for the original function is y is greater than 0. The domain is all real numbers. The range of the inverse is all real numbers. And then the domain is x is greater than 0. And if you notice, these two switch because you switch radio interchange. Pretty cool, right? Graph the inverse. Do it in pink. So that's 4, 2. So you go 2, 4. And then you go 3, 3. and you go 5, 3, so 3, 5. There you go. It's the absolute value of x minus 4 plus 2. The range is y is greater than or equal to 2. The in domain, oh, that's the original function. That's the range. The domain of the original function is all real numbers. I'm assuming it goes on forever. The range now is all real numbers. And x is greater than or equal to 2. All right, 5.2.4. Okay, 85. Have you ever noticed a log key on your calculator? You go to functions, and then it's here, functions, or here. This one, you're assuming the base is 10. This one, you can have a base of whatever you want. So like 5 squared is 2. And this is 10 squared, which is 2. So that's assuming the base is 10. Your task, log base key, done. Copy and complete the following table for the log of x. So it's log of 1. Functions, log 1. Functions, log 2. Functions, log 3. Functions, log 4. Functions, log 5. Functions, log 6. Weird. Functions, log 1. Functions, log 2. Functions, log 3. Functions, log 4. Functions, log 5. Functions, log 6. I'll let you plug those in there. And now we need to find the other side. So 0 equals log base b of x, or 10 of x. So what's 10 to the 0 gets you? 10 to the what power gets you 0? I think it's undefined. So you need to be 1 equals y, and then y equals function log of x. And intersect that to 10. What gets you at 0? They don't intersect each other. It's undefined. Log of x is never equal to 0. When is log of x equal to negative? Plug in negative 1 here, and you get 0.1. Plug in negative 2 here, you get 0.01, 0.001, 0.0001, 0.0000, 1, 2, 3, 1, 1, 2, 3, 4, 5, 6, 1. Use a full sheet of graph paper and make an accurate graph of this. Good. I just use Desmos. Now I want you to know that if you get super close, like it looks like it's touching, but it's actually not touching. So just keep that in mind. What are the possible transformations for the graph? You have a log x minus h plus k. So if a is, this is a vertical stretch, this is a vertical compression. If a is greater than, it's greater than 0, it's increasing, and this is decreasing. If h is 0, this is where it's backwards. So this is shift right, shift left. This is shift up, shift down. So that's normally the graph. That's normally the graph. So now we're going to go up 3. This is right 2. So this is the normal graph. And you go right 2. So Marcus colors Reese. This asymptote is x equals 0. Transformation is up 3. This one is, you moved it to the right 2, so it's x equals 2, and the transformation is right 2. So the look paper is always 1 0 0 1 or 1 0, sorry. So I'm going to left 3, down 2. If you need to draw, you can draw your horizontal asymptote. And when you have like a 4 in front, It just grows faster. Like it just grows way faster. So like if you had then -3 plus 2 plus 3 minus 2. You see how it just grows so much faster. And then this one, log base 2, still goes through here. And then this one just doesn't grow as much. It goes faster. Okay. Plus 3. There you go. So this has an asymptote of x minus -2. Transformation is done to left 3 and vertical stretch by factor of 4. This is up 2, 3, and this is x equals 0. 5-88. You've learned a lot about logs in a short time. Use what you've learned so far to complete the parts below. Why does your calculator compute? So your calculator computes it. It's like your base is 10, so it's 10 to that number has to equal 6. And like 10 to that number, a decimal gets you about 6. Why does it have to be greater than 0? Because 10 to the 0 power is equal to 1, and 10 to the first power is equal to 10. So that's why it has to be between 0 and 1. Cool. Here's your HW, part 3. I'm actually going to do the PDN for next week, so you can watch the PDN for next week on the Chapter 5 review, if you like, for Monday. So these cancel when you just have 4. Those cancel when you just have 27. That cancels when you have just 625. That 2 to the log base 2 of x equals x. This cancels. So you have 7.8. This cancels and you just have b. Write inverse function given the following equations. So x equals -3/5 y plus 4 cubed minus 9. Add 9, x plus 9 equals -3/5 y plus 4 to the third power times by 5/3 -5/3 x plus 9 equals y plus 4 third power cube root -5/3 x plus 9 cube root equals y plus 4 paste minus 4 equals y. Okay. This one is x equals -8 log 5 3x plus 7 minus 1. Ignore that. add 1 and then divide by -8. X plus 1 over 8 equals log base 5 of 3x plus 7. Big 5 cancels. 5 to the x plus 1 over 8 equals 3x plus 7 minus 7 divided by 3. 5x plus 1 over 8 minus 7 over 3 equals y. What are several ways to check your work? Graph, stack, functions, no PDN, and then your chest. So there's the warm-ups for all that. I haven't written your test yet, so that's why I'm not going to do the review yet, because I want to make sure I get the right review problems. I hope this helps. 5.2.2, 5.2.3, 5.2.4, and then week 16. Week 16 PDNs. I hope you enjoy. It's coming down to the end, and I really appreciate what you did period 2. Thank you so much. Always email me if you have questions. PD, yeah. Thanks. Bye.